kidding me? 3 fucking times and it's still too short? What the fuck? You all know that I would never throw a piece of tubing across the shop. It just wouldn't happen. But coping, you're going to find, is a challenge. And it's going to test your patience. And sometimes there are what we call do-overs. But we'll get into that later in this program. First, we're going to talk about our rear swing arm mount and how we made a special riser to set that position in space. Let's get started. I found a measurement that will help us set our swing arm height. So I'm going to create a little riser here with this piece of metal and take a cross piece up to our swing arm mounting tab / plate. So I'm going to drill this to put the cross piece into this. I'm going to drill a hole and then slide it through. So I'm just going to do pilot holes here first. Just going to touch this to see where I want to be. Looks pretty good. Okay. One side. Just going to flip it over and center it here with this piece of metal so I get the exact same position. Doesn't have to be perfect because we're going to level it over on our frame jig relative to the frame jig itself. This will get us close. Okay, all good. Next, I'm going to enlarge this to the 3/4 inch size. I'm using one of these stepped drills, which, you know, they're okay, but for larger sizes, for getting up to the full 3/4 inch diameter here, I know that using the step drill, I'll just go the whole way to get out to the 3/4. We'll just work through this. Too noisy. Probably going to go all the way through, and that's okay. Alright. Just give that a little tight. I've got the cross tube I'm going to use to mount our swing arm plates chucked up in the Atlas lathe here, nothing fancy, but since this is kind of an important part, I do want this face right here on the end of the tube to be flat, to be square. So I'm just going to face this down on the lathe here. Shouldn't be off by much, but I just cut it on the chop saw. See how far off we are. A little bit. Not much. A few thousandths, actually. And you can hear when it's not skipping, you know you've pretty much got it flat. And while I'm at it, I will just put a little chamfer on that. A different bit. Okay, so we'll put this little chamfer on here just to clean up this rough edge. Doesn't need much. Okay, just clean this up a little bit. These inner openings are a little too tight. Not much. Just cleaning that up a little bit so you can kind of get an idea what we're going for here. Here's that cross piece that we just took out of the lathe. So it's built to fit right in the center of this riser. So we'll center this, and that's going to establish a height and a width for us that is very repeatable. I have a bolt that I'll use to then tighten the plates on either side, and this will go here on our central frame rail, centered up, and this is what will center these bracket / tabs that are used to locate the swing arm. I'm actually going to be locating off of this lower opening, which is for a brake lever or some other control, but it's good. I'd kind of like to keep the swing arm open so we can mock that up as well. But this is going to locate this position through the holes. It's going to establish our width, and again, we'll tack this down, and it will be very repeatable, the main thing. And it's also going to establish a distance in this direction to our steering neck, believe it or not, because this is a fixed point in space, which as it travels all the way up the frame tubes is going to locate how this ties into the neck. So this distance is actually very important, and we want to take our time and get it as accurate as possible. I have welded our riser with our cross piece together, and I have put a little cap on the top so we don't have anything fall down in here. And in thinking about this piece, which I'm planning to use back here to locate ultimately our swing arm location, which comes into this hole, but as I was thinking about this, I realized if this is welded to our base plate here, we're not going to be able to get this frame off when we're done. It's an issue to think about as you're making a frame jig is, can we, once it's all welded together, can we lift it off of the jig without having to cut pieces of the jig off? We can always do that if we have to, but we'd really rather not. So the jig is ready to make another frame as needed. So what I've come up with to address this problem is to take this riser and to weld a little piece on the bottom here. I'll have to drill a couple of holes here, but the idea being, unfortunately, we have enough clearance here to do this. So using this piece at the bottom, I'll drill it, and I will do some type of rivet nuts or something in this base that we will then put, a couple of 1/4 inch 20 bolts, so that this piece will then be removable. By mounting it in that way, it will even allow us to place some shims under here to line this up better if needed, to raise it, lower it, even a little bit of fore and aft adjustment by doing it. So that's the idea. I'll go ahead and drill this and weld this base plate on, and then we'll look at mounting this here. I've got a cross bolt that I've welded a washer on the end of, so it can slide into position here and easily be bolted in. So once this is all together, this is going to make a very secure location piece on our jig, again, for repeatability and basically stability of these parts as we're welding on our frame tubes. So anyway, I'll get this ready to mount next and drill the holes necessary. Got the swing arm mount ready to weld this bottom plate onto, and I've gone ahead and drilled the 2 holes that will allow us to bolt this onto our center square tube here. And I've just clamped it to the upper frame rail of our jig here, clamped in several directions so that we get it as square as possible. Just put a tack down. Pick one up back on this side too. That should hold it. Been working on locating our rear swing arm mount, basically riser here, and what I've realized is that I need to get another measurement to find this accurate point. As you may recall, we spent some time up here on the steering neck working on off of this central location and then down. And what I've determined is that since we have increased our rake to 27 degrees, more than a sort of standard featherbed, which is what this is going to be based upon, it's pushed this upper edge further rearwards, further in this direction, which is affecting where our swing arm should be in space. So I've rigged a kind of a contraption here using my T-square, just touching this upper point. I actually attached a piece of angle iron here, but you can see I'm just touching that upper point and then going down all the way down to the bottom. Down here I've got it level off of the bottom of the engine, and I've attached another larger T-square that I have, which goes back and touches this rear frame tube just on the outer edge of this frame tube here, so I can get a full measurement from here to the front of the bike. In looking at this drawing that I have, I can see that amount of distance, it's going to be hard to read here, but it's basically 29 inches from the upper edge of the steering neck all the way back to this point right here that I've identified. So coming back up to the front, we can look here and see that currently, I don't know if you can read that, it's just at 29 3/8. So a little bit too far towards the rear. But I'm wanting to show you this because if I can push this forward, which I easily can, I'll have to loosen clamps. But I'm going to push it forward. I'm going to loosen the clamps, shift the engine, our mock-up engine, this rear mount, and our sort of riser here tying into this bracket. I'm going to push it that way, take a new measurement, and in theory, that's going to give us an updated or modified position based on the fact that we're going for a larger rake of 27 degrees, which is a good 3 degrees more, and it's enough to push the top of the steering neck rearwards. And I can also see I kind of need to come forward because to get this cope on this tube, it's going to be too high, it's going to be up too much, so that needs to come forward so that the cope comes down lower. So anyway, we'll make those adjustments now, and then we'll take a look after I push it forward. Okay, I've made the tweak again, just touching the rear edge of the steering neck, and I've made the tweak to our bottom frame tube and mock-up engine by shifting this whole assembly forwards towards the front of the jig. And you can see now that my reading is right at 29 1/8. So very close to 29, and when I'm looking at where these will cope, I don't really want to push this any more forward because I want these to hit high up on the steering neck. So for now, we're going to go with this position, again, with this whole contraption to measure as much as we can. And also because if you look down on our this riser, again, if you look down on this riser, you can see that our two holes that we're going to screw in here, there's going to be a little bit of adjustment range in here. So we're not quite set in stone yet because we can still shift this riser forwards and rearwards just a little bit with the play on these holes, and if necessary, we can enlarge the holes a little bit more. But this is a good starting point, and I think a good time to mount this rear riser piece with the cross tube out to these brackets. It's a good time to mount this. So we'll work on that. We're going to clear all this stuff off, mark our holes, and mount that piece. All right, getting these two holes drilled for this rear swing arm bracket mount that we've fabricated. I put the base plate on here with some holes which will match these holes down here, and get rid of some of this metal. So when you have basically blind holes, meaning we can't really get at them from the backside, there's different things you could do. You know, you could thread this steel, you could do a lot of things, but one thing I like to use for these is called threaded inserts, or it's these small inserts that fit down into these holes, and they sort of act like a rivet, and there are tools you can use. And here's a manual version where you thread this insert onto the tool, push that in there, and then by tightening it here, you basically compress this inner bottom part that's designed to crush upwards against this side of the 2x4, and it makes a tight threaded insert. And you know, they can take a decent amount of torque, not a ton of torque. I mean, I bought a hydraulic pneumatic version of this tool, as is, you know, frequently used in the aerospace industry. But basically, you just thread the insert onto the tool with the right threaded sort of plug. Goes down into the steel, make sure it's bottomed, and then run it in. And you can feel it. It's designed to stop and then just back it out. So that puts in basically a flush threaded, you know, piece here that we can then position our swing arm mount. Put in I did a 1/4-20 on this because it really doesn't need much torque just to hold it in place. So we would thread in that 1/4-20. I'll put a washer on this first. And that will start to locate our rear part of this swing arm bracket that we spent so much time with in the previous episode. So let me go ahead and thread in this back side. Again, you just thread the insert, and these are available from many suppliers. I don't get no plug intended, but I get them from McMaster.com, and they come fast and easy. Okay, so we'll place that in the hole. It should go in, which it does, and then run it forward, which is going to pull up the bottom end of this threaded piece and tighten it. Happens fast, and then back it out. Okay, so those are done.
It's that fast, lickety split. So again, we can now position this with our bolts thread down in there. I went to this much trouble because I figured out that this piece, you know, once it's mounted here in the frame, we're not going to be able to get the frame off. These will interfere with the frame rails. So the only way to get this out and free our finished, ultimately, frame is to remove this piece first, independently. Now, I don't mind if this can be located fore and aft a little bit, but I for sure don't want it to be moving left and right. You know, there's a little bit of slop in these holes. So I'm going to cut some angle iron and just weld it on either side here, so this is held in position in this direction, and it'll just make it extra secure. For just general cutting, I do like to use this portable bandsaw, basically, here. And it makes a much more accurate cut and doesn't cut as large of a, you know, blade width. Doesn't make quite the mess of a chop saw. So when I can use it, I like to. Just cutting these angle iron brackets I'm going to use on the rear riser to support the sides. So we'll take a look at that. All right, I've got the rear riser bracket here mounted into the threaded inserts with a couple of 1/4 20-inch bolts. I've got my square here anchored to our bottom frame jig rail and tied up against it with this clamp, so I can keep this upper tube, which mounts, you know, on either side, but I can keep it square. And in other words, I know that it's not crooked relative to the base by using this. I've got the two pieces of angle iron that I cut clamped to the sides of our riser, and I've put, these are just a couple of pieces of shim stock I've placed on either side, because when I weld these angle irons, I don't want it to just be so tight that this piece won't even come out. So by clamping in these two pieces of shim stock, when it all comes out, this will give us, you know, these are probably like, I don't know, 3/1000 each, 5/1000. Not much, but it'll be enough that this can come out easily and lift out. So what we'll do next is actually weld on these angle iron pieces, keeping all of our other supports in place to, again, to try to keep this as square relative to our frame jig as possible. Let's tack these down a little bit. One side. Another side. Let's free this up. Take our shims out. Loosen our clamp. Pushed away. Okay, so there's basically where we are. Let's try to free these 1/4 20s and see how well this lifts out. And you can see it's already loose. Okay, so yeah, you can see that lifts out pretty easily, and has just a tiny bit of left and right, which we can adjust that with shims, which, you know, are easy to take in and out, kind of based on what we need. But that's going to allow this to move this way if necessary, but not much in the left and right. Looks like a few thousandths. Anyway, I think that's good. I think it's good. Okay, so coping is a process of cutting and or notching, you know, typically round tubes to shape properly to match either other flat tubes or other round tubes. And I've got a piece here that's coped on both ends just for a right angle mounting. But you want to try to get these, you know, as flat as possible so that the welding, when you actually go to weld them up together, you don't have as many, you have as few gaps as possible. So, you know, trimming this end, notching it, that's what we typically call coping. I'm not exactly sure why it's called that, but it's just sort of a trade word. So we cope this to fit, and then, you know, ultimately they'll be welded on. And again, we want this joint here to be as tight as possible. So coping is the process of trimming and notching these tubes so that they make a good fit and are an easy weld up. This is a different project we've had for a while now. It's actually the TVR project from one of our earlier videos. Hopefully we'll come back to make some more. We've got our swing arm bracket mount reset here on the bottom rail, and everything looks good. Very, very secure. I've also sort of roughed in a swing arm here into the mix just to kind of start to think about where that's going to tie in and how it's going to look as we get a little closer to doing that. So since this is proven to be a really good mounting, now let's follow the frame, this bottom frame tube up again to our steering neck. And the reason I'm looking into the steering neck is really before we can establish where this is mounted on our outrigger tubes here, I need to get this in position on the steering neck. And that means it needs to go over and start to mount like it will finally. So to do that, we're going to have to do a sort of a rough coping setup here on this tube to then put it into position on the steering neck, get the angle correct, and that having that in place will effectively drive a lot of the other mountings down here. So we're going to go ahead and tackle this first take on coping a down tube. Now, I've mounted a piece of tape here just as a guide because I don't really want this tube to get higher on the steering neck. This is a roughly 5/16, 3/8 of an inch, and it could afford to be a little bit lower, but I don't really want it to be much higher because there's not going to be enough room to get a good weld on here. The more heat we apply to this top edge, the more this steering neck is going to distort in terms of where and how the bearing will mount down in here. It's already cut to take the bearing. So we don't really want it to be much higher. Now, how you establish this cope, I've looked at some things, and again, I'll probably link this in the description, but there are several coping calculators out there that will allow you to print a pattern of what your cope will look like. So in this case, you enter the diameter of the steering neck, the diameter of the down tube, and it arrives at this cope pattern, which you can then position on your tube and get a pretty good starting point. Now, the problem with this is this cope is going to be slightly off center here, and that makes it a bit harder. It's also not going to be a straight cope. It's going to be at a slight angle. So we have 2 or 3 different dimensions going here, different angles that make a straightforward cope very difficult. So something I did to get started is I got a piece of tubing here that is the next size up, and it will actually slide down over this tube that we've got to cope, and it will allow me to use this as a guide here, so that when I get the cope the way I want it, I can then just mark this tube with a marker and have a really good starting point. And it's got the repeatability of this basically pattern tube. So I'll slide this off, but pretty much I can see that how this piece is going to fit on the neck and start to address these angles and these issues. So it's also got, I've put a center line on here that I can then transfer over to this tube, and again get a good start on where and how this is going to fit on the neck. So I basically did this cope, kind of an odd looking thing. It's off at an angle, slightly offset. I basically did this by hand, and I just tack welded a clamp on the bottom so we can slide it on here. Now, I've tried many different kinds of methods to cope. Probably most people are familiar with the various systems that use a drill and these bimetal saws that come down. I've got one down below here, or I've got another one over on this shelf over here. I've tried them on a lathe, you know, with a great big milling bit. The problem with these, in my opinion, is they take a lot of lubrication, which makes kind of a mess. They tend to grab, you know, you got to really be careful with your feed rate and your RPMs, and when they do grab, they start to break off these little teeth. Here you can actually see this one I pulled. It's got several of them broken off. So I'm not a huge fan of these. I've used them. What I've kind of wound up with now is I just use a cutoff saw. I'll use a carbide burr on an air tool to kind of get down in there and get some shapes. And another thing I found that's pretty handy is just these roll. It's basically sandpaper on a roll. It's metal, designed for metal, but these allow you to really put some nice shapes, and in the way that you handle this, you can sort of approximate the width of the tube you're coping into. So in other words, what I try to do is several different ways, and somehow, you arrive. In this case, I painted this gold just so it would, not to be fancy, but just so it would show up against the steel, the unfinished steel, so it'll be easy to mark. But you wind up, in this case, with an odd-looking cope. All right, I've got my sort of template or guide for coping in place here on this down tube. I've got a alignment mark at the top here that I think is going to match to a good spot on the neck. So now it's just a matter of tracing the profile that I cut on this larger tube down onto the frame tube. So we'll just trace this down carefully. And this will be our starting point to cope this tube.
on this side here. And down. And just as a sort of just as a rule of thumb on this, you can know that when you mark it, you know, when you trim it, you're going to cut all of the ink off, all of the Sharpie. So all this out here will go away. You know, we want to trim off the Sharpie that's right on this edge to get a tight cope. We'll have to adjust it afterwards with some grinding. But okay, that's transferred, so let's we'll cut it off. Okay, not bad. Again, trying not to take too much at once. So, you know, in just a matter of a few minutes, you know, we have this. All right, just going to use my little sanding roll I have here. I think this is about a 2-inch roll, just to shape this a little bit more. Okay, we've got it mocked up, the tube mocked up on our neck here, and kind of as expected, I can see that it's hitting quite a bit too high. You know, we just in being careful not to trim too much. So I'm going to mark this again and try to get this to hit lower on the neck and a little bit better, a little bit tighter cope all around. So we'll just make a couple of marks where we can see some interference. And then we'll remove that bit and see how we line up again. So, always sort of a learning process here. Okay, so we've got a good cope looking up here at the top. I had to tweak it a little bit. We'll look at that a little bit more, but in the meantime, to get that cope position better, in a better way, I've noticed that I need another place to clamp down here that's going to pull this bottom rail truly, bottom frame tube truly level and horizontal. So I'm going to have to weld in a piece of flat, looks like 1 1/8 or so,
just flat piece of metal on between these two pieces here. So then I can have another clamp up here, which is going to pull this truly level and allow me to set a better position on the top cope. One thing by having the cope better positioned is that I can position this where this is going to go. I've just got a ruler down here right now. I can position this better in and out. In other words, it's going to be at a diagonal, at an angle here. It's not going to be straight across this. It's going to go in at the front, as do most motorcycle frames. So I'm going to cut and position this piece next, and then we'll weld it in place. I'm going to wait to put the angle iron behind here until we get a sort of a final setting on our cope. I got this flat piece of steel. It's about 1 1/8 wide by probably 1/8 of an inch thick, and it goes between these two outriggers at an angle approximately so that this bottom frame tube will rest right on here before it goes up to the steering neck. And this is just going to allow me to get better clamping, 2 or 3 as needed in here, to get a final position on where we cope our frame neck piece. So I'm going to go ahead and tack these in position. These are, as you can see by the way I've got this clamp, these are flush with the top surface here. I don't want to add any height here to throw things off because we've made all our careful measurements. So I'm just going to use a piece of very thin welding rod here because I don't really want to build up anything above this level. So we'll just tack these down. Magnet throws it off a little. I'll start with this rear. So we'll put a couple more tacks on that, and you can see how this is flush here. And I'll grind off the welds, and we'll reposition our bottom frame tube. Okay, just going to flatten these down a little bit to make sure there's no interference on our bottom frame tube. Hit the back. That's going to work very flat and rigid. That looks good. Okay, got the frame tube, this lower frame tube back in place here, and I've got it resting on the flat piece of bar stock welded between our two outriggers. And I'm just going to take a moment to check this positioning with this primary case, inner primary. Again, just kind of get this up here roughly in position, and I'm checking. Now we're actually getting a little bit of interference back here, so it's like the engine is shifted slightly rearward, and I'm also getting, just looking at the alignment of these mounting bolts for the primary, I'm seeing that it's like the engine itself, the cases need to go up. So I'm just going to take a piece of flat stock again, and place it under this engine and see what I can do by raising that slightly. Got a level up here. That does help in that the mounting studs, the mounting bolts would go in here pretty straight. It looks like it actually needs to go up a slight bit more. I'm also getting a little bit of a shift here, a little bit of interference back here, which we can kind of tweak by shifting this rear mount forward so that the transmission mounts actually shift. So, done that. I mean, we are very, very close back here. And I have a feeling if I raise this just a tiny bit more, I'll have to find one of my shims and do that. I think we'll be in good shape to carry on mounting our angle brackets back here to position these frame tubes. All right, I've put a couple more shims under the cases to raise that just a bit, and I'm checking here on these mounting locations. The inner primary needs to go up here at the rear to get these 3 bolts to line up, and it looks like they do. So that would alleviate the interference back here, and I think we've got a good position. We also don't have any interference down here under the primary, the inner primary. There's nothing hitting, not even close to the bottom frame rail, which is great. So, you know, another little interesting note here is this. I've just got a rough level here on the top of the cases, and you know, a little known fact, an Atlas or Norton Atlas cases actually were tilted slightly to the rear. You know, the commandos come way forward. So we're kind of in keeping with that we're on the front side of this bubble level, meaning the cases are actually slightly tilted to the rear, which matches generally the original design. All right, we've got our, up here at the front of the engine, we've got our angle bracket here clamped roughly to this outrigger in order to position the in and out setting for the front down tube. So I've also clamped it back here in the back. But anyway, we've got a good position to tack this angle bracket down, again, to locate where this is going to be in space, since we have it well marked up at the steering neck. So we'll just put a tack on either end of this. All right, so continuing here with this whole front part of mounting this bottom frame tube and getting everything aligned, since we've welded on our angle brackets here as a back stop, so to speak, for this tube, I've started to look at this front isoelastic mount, and I've installed a couple of the original Norton. These would be commando parts from the early type rubbers, and I've found a bracket that I have, actually this one that I cut in half is made by a company called A&A Manufacturing. Great company, they ship fast. No plug here, just have used them over the years, but I found a bracket here that's very similar to an original commando bracket, frame bracket. Needed a little bit more length here, and I've kind of got it mocked up here on the front part of the engine and up to the tube, and you can see it actually fits pretty well. You know, there's been a lot of Norton Commando engines mounted in featherbed style frames over the years, and they always have this, you know, the Commando forward leaning engine, which to me always strikes me as looking odd. You know, I know a lot of people like it. You know, to me it's not quite what you expect in a featherbed style frame. They're fine, they have their advantages, but I just like the look of a vertical mounted engine in this style of frame. So anyway, you know, we're out there on this of using this isoelastic, but if there's a way to reduce the vibes here, you know, and I had a couple of Commandos over the years. I actually had a 850 Commando with 1,200 original miles on it back in the 80s, so I'm pretty familiar with them. And this isoelastic system does work quite well when it's set up. I have something else in mind in terms of how this would mount rather than using shims and things. So we'll see how that goes. But, you know, I'm tempted to go ahead and tack this bracket in place here. We're a little early in the game, but I need to find a reference point to secure this bracket to the frame jig once we remove this mock-up engine. So we would still want to be able to locate that. So this might be a first step to go ahead and tack that in and then look at mounting some sort of riser here, kind of like what we did in the back here with this riser to get to the swing arm. So we might do something like that up here on this front part. But I think I will just go ahead and put a little tack here so I have this as a reference point. Okay, let's do a couple of tacks on this front engine mount here. Just as a starter. Hard to get in here. Ugh. Okay. Okay, we're just going to take a minute here to transfer what we've learned on the left side of our frame here and transfer it over to the right side so we can kind of take the next step in this mock-up. But basically we've put a lot of energy into these pieces and we want to transfer them over here to match. So I'm just going to tack weld these in position. Keep these tack welds as low as possible. We don't have much to grind off. Alright, again, measuring these several times to get a match. Okay, so we've taken the time to copy our left side positioning over to the right side of our outriggers here on this bottom tube of our frame jig. So we've done our best to match this. I've only put down tacks because, you know, we may have to tweak that a little bit down the road, but this is going to allow us to put our second frame tube on the other side and then start to look up at our neck and see how everything's fitting, including this rear mount. So with two tubes we're going to get a better idea of where we are so far. Okay, we've taken the time to transfer all of our outrigger material here to set up our guides just to match the left side of the bike. And I've gone ahead and added the bottom frame tube here just like we did on the other side. So I'm basically just catching up this side. And you can see that that's all in position and doing well. I also added this front isoelastic mount to match the front left. So we're still doing well with that. And in adding this lower frame tube, we now have it up top here. I've removed the steering neck just to make this easier to see. So we've got our two down tubes. And I've taken a piece of paper template as a way to transfer the left side tube over to the right side. And what we'll have here is basically this side tube is going to be a mirror image of the left side. So what I planned, and again you can see I've cut this so that it just matches this basic cope that we have so far. So what I'll be doing is taking this template off, and I'm going to cut it, basically cut it, and then wrap it around the left side the opposite direction, and I'll do that here in just a minute, so that this cope will be a mirror image of this cope. So using my paper template, I'll transfer it over with a marker, and then we'll be able to cope this side, since we have a left and right. Again, just a mirror image. Okay, again, we'll just slide this template off, and I'm going to cut it on the back side, which has a seam here. And then by wrapping it, you know, basically flipping it 180 degrees around so that it's a reverse of itself, and I'll put a piece of tape across this back, turn a little bit of manual. So now, since I have 180 degrees of this, in that it's been flipped around the opposite direction, I'm going to be able to position this just so this edge is touching in the same place. We'll do a couple of measurements here, but the point is you can see that I can then take my marker and copy over from the exact same template that was over here, but again flipped 180 degrees. So that's going to allow me to make a mirror image here of the same cut, so that the two sides are going to wrap around the steering neck very well. So we'll go ahead and mark this and then cope it next.
Just touching up the copes on our two frame tubes here, the down tubes, and we can see that our two copes on these front down tubes have worked pretty well. Just using some of the techniques that we've talked about in this episode, and we can see that these are going to fit pretty nice and tight. And you know, it's time to move on to the next thing. But in this episode, we've seen that, you know, coping is something you can do, but it takes time. It takes a little bit of practice. It takes patience, but it definitely can be done. And you need to use some of the techniques we've covered about using paper to transfer over, or making a separate piece of tubing that you can fit and then transfer over. So you want to use as many ways as you can to accurately transfer the cope. In the next episode, we're going to talk more about our isolastic setup on this build, using the NORTON isolastic system, which is, you know, works pretty well. We've already covered some of the front isolastic, but we're going to get into maybe one or two more isolastic system setups on the rear of the engine. We'll get into that next, so please like, subscribe, and we'll see you back soon. Thanks.